Welcome to the Archives of IT. Scientists, technologists and medics talk here about how they have used computing, data and communications in medicine. Kevin Warwick talks about connecting computers to the human brain. Kevin was branded Captain Cyborg in 1998 when he had a digital device implanted in his body. Kevin now works on how computers and AI can work with the brain to support people suffering from Parkinson's disease, as his grandfather did, and might address a whole range of other issues through neurological interaction.
So I went to my GP, George Boulas, and said we would like to do this. And fortunately, very quickly, he said, yeah, he was happy to implant it in me, which was great from my point of view because I was worried about how do we sterilise it, what's going to happen in the body, would there be any problems and so on. So then it became partly between him and me that we were working on it. He was coming, yeah, we can sterilise it like this. We tried in the lab, you sterilise something, you boil it in water. So we put this first one of these implants, it became an implant, it wasn't really an implant, put it in water and boiled it, and it exploded. Right. We had bits of chip and glass and everything all over the place, so that was no good. And what George suggested, well, to put it in an enclave, this oven, and that would be sufficient. And that was what he did. He sorted that bit out for us. But subsequently, in 1998, that was implanted in my left arm. Still a bit of a mark there, but not much. And I became the first human in the world to have a radio frequency identification device implanted. And it got a lot of publicity, which more than expected. But it worked. I have been for many years now working with Tipu Aziz, who's the consultant neurosurgeon at the John Radcliffe in Oxford. Brilliant guy, and it's an honour to be able to work with him. But what we do, he uses deep brain stimulation, which is applying pulses into the person's brain to overcome the effects of Parkinson's disease, also for epilepsy and depression in some examples, so it can tackle a number of issues. But what we do is also record the electrical activity in the person's brain and feed it into an artificial intelligence system, and we try all different types of AI, and that learns it models effectively part of the human brain for two main reasons. One, that it can predict when the tremors and the muscle locking that's associated with Parkinson's disease, when it's going to start, the AI system can predict before it starts. So that you can then apply stimulation to stop it only when it's needed and not all the time. Secondly, it can also classify. It can say, well, it's actually this type of Parkinson's disease, type A, if you like, or it's type B or type C, based on the electrical activity in the person's brain. And that helps Tipu and surgeons say, okay, this person has got type A Parkinson's disease, therefore they need this stimulating current, they need this, they need that. So from a medical point of view, it's given a diagnosis which you wouldn't be able to get otherwise. And that for me, I mean, I have to say it's wonderful to be part of the research that you feel that you're actually helping people directly. But it's a horrible disease which my grandfather had, and it's just a shame that I can't go back in time. If someone now invents a time machine, I'll go back and help my grandfather straight away. I think the implant that I've tested out, the BrainGate, or similar implants, can be used to help people with different disabilities, such as paralysed people. I think generally, even with the deep brain stimulation, there are a lot of neurological problems that we have at the moment remembering the brain is electrochemical, that we can tackle electrically. Schizophrenia is another one. If we knew the best position, the right type of signals, I believe potentially we can overcome problems such as schizophrenia with electronic medicine.
Right.
We just need to find out how to do it. But surely we've got to be able to do it. So that's again another positive, and it's more short term. It could be tomorrow. Hopefully they will win the Nobel Prize. But I think there are a lot of people that have a problem. A lot of people don't even admit that they have such a problem. It's part of the disease, you might say. For a third of people with schizophrenia, they're almost incurable. We just don't know what to do with them. So this overnight, and it's not just the people themselves with the problem. It often affects all of the family around them because of how the person is, and people giving up lives to look after them and so on. So I think a lot of neurological problems, and there's one example, will be transformed in the short term years ahead.
So that's kind of electronic medicine.
Electronic medicine. Yeah, I mean, it could be in the future. You have a headache, zing, you put in some electronic signals. A headache, why not? It's just a neurological thing.
Each of these short videos describes a medical breakthrough made possible by information technology, in the words of those who achieved it. For more detail and extended interviews, visit our website at archivesit.org.uk. We are grateful to the support of the British Society for the History of Science for supporting this project.